Welcome, everyone. Thank you for joining us on our second session of Amplifying F#. Today's session, we are really happy and excited to be joined by Chet and Jimmy. They are maintainers of Ionide and also contribute to a lot of open source projects like FSAutocomplete, the compiler, Fantomas. So yeah, thank you very much for joining us. So before we start with the session, I would like to tell you a little bit more about Amplifying F#. Amplifying F# is an initiative that encourages hands-on collaboration in the open source community, especially F#. And we aim to inspire people who wants to chime in and contribute to the open source community. And for that, it's easy to join us. All you need to do is go to our website, which is amplifyingfsharp.github.io, and on here you will find our homepage where you will see our mission statement, and you can see what's the problem that we're trying to fix, why we want to give it back to the community, who we are, and especially how what to contribute, and yeah. So you can see here also the sessions that we have planned for the next future. We have last time we had a session about the compiler reporting, which I presented, and today we have the session for Ionide and FSAutocomplete, and we will be including more sessions during the next week that we are closing right now. So on here you can also see that how you can join us. You can join us by fill this form where we ask you small questions. What's your name? What's the company you represent? What's your time zone? What's the topic? What's the issue that you're trying to fix? Can be a specific issue that you are trying to fix, where we will ask you to include a link. It can be that you want to work in a specific project like FSAutocomplete, Fantomas, Fabulous, any open source project, basically. And then if you're not sure what you're trying to do yet, you can tell us your idea, and we will be able to recommend you or kind of guide you through how we can tackle that. So for today's session, we have the Ionide and FSAutocomplete, and in a few moments I will hand it over to Jimmy, who is going to explain us a little bit what's the problem we're trying to fix, and yeah, we will take it from there. So yeah, let me make Jimmy host so we can start from there. So yes, so Jimmy, I'll hand it over to you.
All right. Let me start sharing my screen. Well, hi, I'm Jimmy Bird. I am a maintainer of Ionide and FSAC. You may also know me from other repositories like Miniscaffold or FS Toolkit error handling. I've been doing a lot of maintenance in open source world for quite a long time. I'd also just like to thank, I work for a company called Motivity. I'd just like to thank them for letting me spend some time on doing some open source work here. We focus on dealing with ABA and development therapies, specifically in autism, and our stuff is powered by F#. So that's the cool thing, right? Not anything else. But talk about the problem. So the lead from the what I do at work, we have a giant F# code base. And one of the things that we want to deal with is using VS Code and all its really great capabilities. And but when you have a larger project, a lot of the tooling that we have around F# can be a little slow in places. And in this particular case, this one is one I identified in our project, but it also exhibits itself in some other projects like Fake. And so when you have the Solution Explorer up in VS Code, we'll navigate to that pretty soon, and you try to actually move a file, it can be quite a slow experience. And if I can actually demo that being off here, So we come into the Solution Explorer here. If I wanted to actually move up this operator with this little keyword or this little click here, it's going to take a little bit of time for that to actually like show up. As you can see, it said it was loading projects. Took about 7-10 seconds or so. A little bit slow. And so what we're going to be doing today is kind of just walking through and trying to figure out what would be the best way to fix this in our entire stack, mainly because we have a really big stack here, and we're probably going to cover a little bit of that.
Jimmy, before we get too much further along, couple sort of nitpicky technical streaming questions. What resolution are you streaming at right now?
Oh, I do not know. That is a great question.
I think you are streaming like your native display resolution, which I think is
Probably
pretty
is.
big.
Okay. So I need to be a little bit higher in resolution on this. How about this?
Well, it's more that
or I need to actually change my monitor size.
Yeah, you might have to like go to 1080p for presentation purposes or whatnot.
Probably. Let's see. How do I actually change this stuff? Scale big. All right, let's go down to 1920 by 1080. Let's keep changes. All right. So looking better.
Let us know in the chat and stuff.
Yeah, maybe if you zoom in a little bit. I tried to look at the session from last week, and it was quite hard to follow along. So I know it might be a little bit more awkward for you to look at this, but then the recording might be actually more usable.
Yeah, absolutely.
Okay, thanks.
Sweet.
Yeah, just
so,
is it looking good? Is it looking better now? Just let me know before I go too deep into all this.
I think that should be quite comfortable now.
Okay. All right, Chet, go ahead.
Awesome. Yeah, sweet. So Jimmy just sort of set up the problem statement, who he is, who I am. I currently work for Microsoft as the PM for the .NET SDK, MS Build, the templating engine, and all those things. But for a very long portion of my career, I worked at... I'm sorry? Anyway, I used to work with Jimmy. I've done a whole bunch of F# professionally and in open source. And I maintain FSAutocomplete and Ionide and a whole like host of sort of community tooling. So the hope is that with both of us here, we can sort of describe the lay of the land, like how all the different parts that make up Ionide and VS Code come together, try and identify where the problem is surfacing, and then talk about some different approaches to solve it, and then solve it.
Yep. So let's take a slightly step back to kind of like looking at Ionide as a whole. So let's actually come over to ionide.io. One of the things I did recently is I actually put together a little mermaid chart, kind of about like Ionide and all the things that are kind of connected. And if you look at this, this looks like quite a bit. I do kind of want to, I'll walk through it a little bit here. And so the portion that most people are familiar, or many people are familiar with, is probably VS Code, but technically this Ionide is part of a bigger ecosystem with having a lot more editors and more support. So there's Emacs, there's Vim, there's other LSP clients that have varying supports. And so we actually have more than just VS Code, but in our particular case, we are dealing with VS Code. So we can walk this kind of chain here. And so when you deal with VS Code, there's actually the Ionide plugin itself. And so this is something that we install alongside VS Code to basically interact with our what is considered a language server. And FSAutocomplete is that language server. And so the basically all the real brains behind how you get IntelliSense, you get errors. A lot of the work is code fixes, all that stuff is in FSAutocomplete. And it relies on many other things as well. And this what this comes down to is it relies on proj info, which is how we actually communicate with MS Build to actually get some information out of your project files. So that's how we know where like your packages are, which things you referenced. And then the other really big thing here is F# compiler service. And this is the brain behind pretty much all editor tooling in general. And this is where we rely on the F# compiler itself to give us a lot of the real information that we need, like the errors and whatnot. And so today, one of the things I outlined is probably the couple projects we want to look at, and where we probably need to think about where we're going to do our fix. And this is going to be either potentially in Ionide, the plugin for VS Code itself, potentially in FSAutocomplete, or potentially in Ionide proj.info. And let's see.
Sweet. Yeah, so talking in a little bit more detail about what's happening when you use any of the, well, actually, let's go back to VS Code real quick so I can make a point.
Yep.
So Jimmy was just sort of pointing out there is Ionide VS Code F# VS Code, and that tool uses FSAutocomplete to provide features, right? Ionide VS Code F#, I'm just going to call it the VS Code extension or Ionide from now on, is the thing that's actually providing the solution explorer you see on the left. It's using data that comes from FSAutocomplete, but FSAutocomplete doesn't just send like a serialized representation of this tree here. This is code that lives in the Ionide extension and is interpreting data that comes from FSAC. And we'll talk a little bit more about that flow in detail, but right now, as far as I'm aware of, Ionide is the only language server protocol client using FSAutocomplete that does this sort of presentation. If Ionide Vim or the Emacs plugins or the Sublime Text plugin wanted a similar experience, they could probably port the code from Ionide and get a pretty close representation. But the problem that Jimmy is showing, or that the problem that Jimmy has brought to us today, is very much an Ionide specific presentation right now. So over to the sequence diagram. I don't often do these things, but it seemed really helpful in this case to sort of talk about what happens when you trigger any of the commands on that Solution Explorer view. So we have a few sort of primary entities that we're talking about here. We have users who are interacting with Ionide, who is interacting with FSAutocomplete, who then has all these tools to provide information or feedback based on the user's interactions. So specifically for the case of adding a file to a project, but the same flow happens for removing files, moving them around, etc. Here is what happens under the covers. So the user is going to add a file to the project in Ionide. That causes Ionide to do basically an RPC call to FSAutocomplete. And that RPC call has a name. It's fsproj.add_file. And as a result, FSAC directly modifies your project file. Like it writes the new file as a compile item in the file list in the project file. And then it returns. It says, I'm done. What happens after that is there is this component in FSAC that comes from the proj.info library. And this is called the project system. The project system is something that's initialized when you start up FSAutocomplete. And its job is to identify what solution or folder or projects you have open them for the first time and do a bunch of checking on them and get a whole bunch of metadata out, and then sort of listen for changes to them and emit events or notifications when those changes occur. And that's exactly what happens here. When FSAutocomplete modifies your project file, the watchers on the project system say, hey, a change happened to this project file. I need to go ask MSBuild to do some things so that I can evaluate the contents of this project file and then notify FSAutocomplete that this has changed. FSAutocomplete then notifies Ionide that a project configuration has changed. And then Ionide uses that notification to update the tree. So what I think the cause of the delay is here is this sort of disconnected evaluation here. Now, this flow that I just talked about, there sort of has an asterisk on it because it only works for one of the language server implementations in FS Autocomplete. Jimmy, do you want to talk about the distinction between adaptive and normal?
Yep. So let's go do that. So a little while ago, I started working on specifically something called the adaptive LSP server. And when we actually look at like what's in FSAC right now, we have the FS Autocomplete LSP server, which is what people have been using for multiple years at this point. And one of the things that is, and people have probably rightly gotten this way, it's very frustrating sometimes of experience in VS Code. And this is because keeping track of all the things that need to happen for you to be able to get type checking and error reporting is kind of difficult. It's really hard to get down. And, working on editor tooling in your spare time is not everyone's relaxing hobby. But one of the things that Chet and I have talked about a long time ago was potentially using something called F# data adaptive. Let me pull that up. And if you're not familiar with this library, F# data adaptive is this library that kind of sits in between the notion of like reactive related things. And so like reactive is more about events occurring. And so, this would be like your watcher notified changes, seeing these kinds of, actions that happen. And then it's also a bit lazy in terms of it doesn't recompute until it needs to. This is kind of one of the things that reactive, it's a little bit harder to get right, meaning you need to have some type of like, whenever you react to events, like you're always reacting to them, you don't really have a more notion of when you want these changes. And so we've talked, and the thing that's really powerful about F# adaptive is it is able to model this kind of like dependencies, the things that you need in order to actually get at something that you want some type of value. And so one of the things that's slightly different from the original implementation and the adaptive LSP implementation is the regular LSP implementation just kind of relies on events and trying to deals with like the state management and making sure that those things work. It'd be a little bit easier to show an adaptive what the dependency tree kind of looks like, just because it's about kind of like modeling this kind of idea of like, I have these set of inputs and I need to derive a set of outputs from these potential inputs. And so at the very high level, what's the thing that we need to start with is we actually need to get some information from your project files. And so when I come down, let's look for cvals. So there's this notion of something called a cval. This is a changeable value in adaptive. And these are basically like your direct inputs. These are the things that if these things changes, all your potential outputs could potentially change as well. So if you're thinking about like modeling like a gravity system or something, one of your inputs would be like the constant of gravity for like the Earth. But if you're modeling something on Mars, that's going to be different. So you'll be able to change that and see them kind of more happen and be able to model that. So in our case, we have multiple inputs, which is going to be the root path, which is actually where your workspace is in VS Code. some configuration values that get passed in. So this could be anything from, pretty much anything you see in the settings for F# itself. And then where we actually get that information, which is the workspace loader. And this is where we talk about FSProj info. And so this, we'll see a little bit detail what this is different in either server. And so this relies on, let's go actually find where this loader is being used. And so there's this idea of loaded project options. And so here we can see this is basically creating the dependency tree of like what is happening here. And so we have this notion of where we want to actually get the loader, which is loading project information, and our paths. So if either of these change, we would actually want to recalculate all this information. And this is kind of done ad hoc in the regular LSP server. These kind of like dependencies are there. They're just not very apparent. They're a little less obvious, like what things are relying on what things and how state is tracked.
One of the parallels I kind of draw in my mind is if you've done like WPF before, you may be familiar with like annotating every view model property with like iNotify property change, so that changes to it propagate to things or to other properties that consume that base value. Adaptive or F# data adaptive is a way of making that very explicit. And Jimmy could not be more right when he says that a lot of this sort of change detection logic was done very ad hoc in the standard server. So there are sort of two really good benefits of using F# data adaptive here in my mind. One is clearly calling out the dependencies, the inputs to a particular change. And the second is having a really nice concept of the current state while not losing that ability to change the current state easily. One of the nice things I have found about the adaptive server implementation is that it seems to drop data far less often than the standard server. So like you just might lose some project options using the standard server because we were manually trying to do a lot of the same things that data adaptive gives us for free. So I'm a big fan. And like for the record, our goal is to make the adaptive server the default in like the short to medium term. So /rant.
Yeah, it's been a nicer experience, and I've been dogfooding this a lot on my work project, so I know it handles fairly bigger projects pretty well. And if you haven't turned it on yet, I guess I should tell people how to turn it on. If you go into our settings, and if you just type in for adaptive, there should be this enable adaptive LSP server. And it seems to do things a lot better. It notices like installation of new packages better. So it notices like changing branches better. It seems to do that. Like I said, there is a lazy component to it. So let's say you did a get change outside this repository, until you actually ask for like some type checking information, it's not going to go and recalculate stuff. So you may do a bunch of work outside and it's just not going to do anything until you really ask for some information. So it may seem like nothing happened until you actually like interact with it. And that's kind of intentional right now, because it's better than burning your CPU until, all the changes are actually changed and you actually want that information. So that's kind of the lazy nature of it.
So why are we talking about the two different servers here?
Right. So
we're talking about
right
them
here
because
they have different implementations of using this workspace loader.
Yeah.
So if we actually track where this workspace loader, let's see, let's go into the state object. So we have this idea of a state FS file. And this is supposed to track all the changes and what the current state of things are. And so LSP uses like both LSP servers uses the same workspace loader, except the difference in FSAutocomplete's original LSP server is it uses something called a project system that is provided by FS Proj.info, while Adaptive uses more of the primitives and establishes its own kind of like project management system. So it notices how changes or notices changes differently. And the big thing is Adaptive is a little bit naive in how changes are propagated. And so if any of your projects change for any reason, it reloads your entire solution, which maybe, that's obviously the cause of the issue that I'm bringing up, is it's when one small change happens, it needs to do an entire design time reload. Should we talk about design time and evaluation?
I was just going to say, Jimmy just said a phrase there, design time reload. So on the big chart of components that go into FSAutoComplete, one of the nodes on there was Proj.info, and another one was MS-Build. Why do we care about building for IDE? Why do we care about MS-Build for IDE tooling like FSAutoComplete? Isn't that something that just happens when you run .NET Build on the command line? The answer is no. All editor tooling you use, if it wants to be true to what is going to happen on the command line, needs to interface with MS-Build in some way. And it needs to do this so that it can get the same set of information that .NET Build does. The worst thing you can do is be in an IDE and have your IDE behave differently from a command line build, because then a developer is just confused as to what the source of truth is. So we need a way to interact with MS-Build and get out information that the compiler will use. And mostly for F#, this comes in the form of a type called F# project options, which is a type defined in the F# compiler services. And part of the job of Proj.info is to handle, sort of abstract away requesting information from MS-Build about a particular project and turning that into a F# project options object that the compiler can then use to do type checking for errors, to do IntelliSense, to do syntactic highlighting, right? All of these fun features, code folding, navigation, all of the things that you need come down to having an accurate set of project options. So we made Proj.info to sort of, well, for two reasons. First off was I was getting a little frustrated dealing with MS-Build directly. And secondly, because there is a lot of, well, we use MS-Build in an interesting way in FSAutoComplete. We host it in process. That means the MS-Build that ships with your .NET SDK, we are actually loading into memory. We're not shelling out to call .NET Build with custom targets or anything. We are hosting the process, the MS-Build evaluation in process. So the job of Proj.info is to sort of paper over all of that and make it nicer to use. What it actually does, in most cases, is called a design time build. A design time build is a build that an editor triggers on your project that does not actually result in like compiled outputs written to disk. The goal of a design time build is to do as little work as possible to get the same results as a build. And there's a really complicated set of MS-Build targets that you have to trigger, and you have to pass in a set of properties. Like it's a whole area of deep magic that you can go into. And Proj.info is our best summation of all of that work. But the point being, Proj.info is the thing that is responsible for interfacing with MS-Build in that way, and it does two primary things. It evaluates a project, which is the act of reading a project file, an XML project file, and doing all of the implicit imports of all of the .NET SDK provided props and targets files and things like that. And this is so that you have a full model of the project with all of the targets available in it. And then the second thing it does is call specific targets. And you can see these design time build targets on the right side of Jimmy's screen there. These are all the targets we make sure that we call, and they're all important. And if you call them all correctly, you should end up, the result of that should be an object that you can ask about properties, various MS Build properties and various MS Build items. Once you do this, you can then extract those. And here's the list of properties that we pull out right now. Editors like FSAutocomplete can also pass in additional properties to grab. But the ones that we really care about are things like, hey, what command line options did you pass to the compiler? What target framework are we building for? Where are the outputs of this project stored? Right? Those sorts of things, those properties are useful to enable like F5 debugging so that we know what to launch, right? So so that's the role of this entire component, is to handle that mapping for us. And then, as Jimmy mentioned, there's a project system component that tracks changes to projects all the time and fires off event notifications as well. There's a hand up on Zoom. Is it Yo?
Yeah.
Did I say that correctly?
Yeah. So if I understand correctly, you are using MS Build like a library, right? Is that correct?
Exactly that. Yeah.
Okay.
There are some subtleties to it.
Okay. Okay. So, but this is how it was designed, that you can call it as a library, and then you basically call it like whatever, some calls on it, and then it would return all this information that you're looking at.
Yep.
Okay.
Ionide Projinfo mainly uses the MS Build libraries, like the sort of API surface that you can get off of NuGet right now. So you can go load the Microsoft.build packages from NuGet.org right now and do your own evaluations. There is a caveat to that, though. Those packages actually include the DLLs, and if you are naive about the way that you include them in your project, you will actually, like, you will try and load MS Build from your application, when what you generally probably want is loading the MS Build from the SDK so that you can behave in the same way the CLI does.
Okay, so this is the tricky part.
This is the tricky part, yeah. Okay. So there is a component called, there's another package called MS Build Locator that, or you could use Projinfo to help you get around this. But both of these projects, I think it might be called Microsoft.build.locator, Jimmy. Or something like that. But the point of this is an algorithm to help you find the appropriate set of MS Build libraries to load. So this is part one. And then part two is changing your project so that you only reference the NuGet libraries at compile time and not at runtime.
Okay.
It's a two-phase thing. There are docs, I think, on Projinfo that describe it, but MS Build Locator also has docs about how to set up your project for that. If you do these things, you can use MS Build in process, which is nice because you have full control over it. If all you need is a way to execute builds, like in a one-shot fire and forget kind of manner, you might be better served into looking at libraries like Buildalyzer, which is a tool made by Dave Gluck. And it does a lot of the same things that Projinfo does in terms of doing a design time build, getting those properties out, but it does it purely from executing .NET build and injecting code into that build that it can then read out. So it tends to be a little slower end to end because you have process startup overhead, and it is not as good if you are going to be in a long-lived scenario.
Yeah.
Right.
Cool.
So that's sort of the trade-off there.
Can I have another question related to the FS autocomplete, like about the picture you were showing before, where it said that
the sequence diagram, or the
the sequence diagram,
graph?
And it said that FS autocomplete directly changes the project file here. Yeah. So can you tell us a little bit more about how so my understanding at the moment is that FSAutocomplete is using this language server protocol, or what's the correct name? I don't know.
That's the correct
That's what it
name.
is.
Okay, and it can directly access the files in the VS Code. Is that the idea also?
Yeah, yeah.
Okay.
So without going into too much detail about it, when you
So
open,
I apologize. This is like out of scope for now, but maybe
it might be relevant. We haven't talked about like how the Solution Explorer gets populated sort of initially. But when you start Ionide for the first time, the first thing it does is something we call a workspace peak. And that's configurable with some settings on Ionide's side. But what workspace peak is supposed to do is look at the current opened directory and find solutions or directories that contain a bunch of projects, etc., and have you pick one. And when you pick one, sort of open that thing up, find all the projects in it, and use all of those projects to sort of load into that workspace loader that Jimmy mentioned a little bit earlier. And so that discovery and initialization portion is fairly complex, but all of the data from that workspace load command that you can see on line 4011 there, all of the project load events that get fired from the workspace loader as it's loading those projects, all of that data is being received by Ionide in the form of event handlers, basically. And all of these projects then get added into this tree structure that VS Code renders.
Okay.
So that's sort of the whole process there. FSAC, when we add a file to it, when we remove a file to it, it's being very, I'll just say it, it's a very simplistic implementation here. We load the XML file, look for the specific node, and we modify a node specifically. We're not looking, there's no sophisticated abstraction over a project file that we are manipulating currently.
So if I understand correctly, then the Ionide is more responsible for this left-hand.
That's exactly right. Yeah.
The Solution Explorer, whereas all the information, like when you hover a specific type or whatever variable on the right hand in the code, this is actually FSAutocomplete.
Yes,
is that correct?
And sometimes finding the distinction between those things can be a little ambiguous. The split is mostly core editor features will come directly from FSAC.
Okay.
Any Ionide specific treatments. And so this means things like the Solution Explorer, things like the integrated debugging, things like info panel. These are all Ionide extensions, but the goal of all of these extensions is to be built on data coming directly from FSAutocomplete, because our aim is that info panel shouldn't be it should not be Ionide only. It should be possible to implement in Vim, right? You could imagine a Vim command that opened up a new buffer with all of the same detailed documentation info that the info panel has, right? All of that should come from FSAC as the source of truth.
That really helps. Okay, thank you.
Absolutely. Yeah, so here's the actual implementation of the command that Ionide triggers inside FSAC. You can see it's very simplistic. We're going to open a document. We're going to an XML doc. We're going to load it. We're going to use XPath to find the particular file that we care about, and we're going to add a new node above it, or we're going to add a new node below it, or we're going to remove that node completely, etc. So there's a question in chat. I'm repeating these because I don't think any YouTube recording will have them in the future. But Functionally Dysfunctionals asks, so MS Build and Project System, or Adaptive's equivalent of the project system, reacts to file system changes directly, ? As opposed to some sort of MS Build or .NET signal? Yes, that is exactly correct. The the project system and Adaptive's parallel version of it both use file system watchers to watch an interesting subset of files. So at first you might say, this is just the project file, right? No, that is not the case. There are certain files that get added as part of restore, for example, that if you watch those, you can respond more quickly to changes in like package dependencies, for example. There are MS-build extensibility mechanisms as well, files like directory.build.props, directory.build.targets, and these things can also impact the sort of final model of your project, right? They can set properties, they can add new items, they can take items away. And so it's important that we watch a good number of them, because so that we have an accurate view of the world, right? So you can see some of the more interesting ones here. Obviously, we watch the fsproj file itself, the project assets JSON, and all of the props files inside your intermediate output directory, which is commonly obj, are really interesting because they have to do with your NuGet dependencies, right? This is a horrible gross file. I hope none of you ever have to go in here, but this is what restore generates. Even if you're using Packet, you end up with this, right? And so this and all of the props files in here, we use as a signal to know when to reload. There are also, you might say, maybe there's a need for an out-of-band update, like an explicit update. Sure, no problem with that. And with Jimmy's adaptive model, it's very easy to add in that explicit signal to refresh if you needed to. And that's one of the things that makes me so optimistic for the adaptive servers. It's very easy to sort of add these new items in a cross-functional way. So zooming back out, we talked about MS-build a whole bunch. Because we have these two LSP server implementations inside FSAutocomplete, and because we would like to not do work twice, I want to propose like a design guideline for any solution we find to the original problem here. And that guideline should be, let's do something that works for both servers in one place. Like I don't think that's very restrictive. How do you feel about that, Jimmy?
I think that's a pretty good. And then we have to decide where would that be? Is that something in project info, or is that something is there something higher up, or is there something at the UI level?
Yeah. So if we know, let's talk about what we know. So we know this is a user triggered operation, whether it's add, remove, etc. This is not something automated. So we know that a user has explicitly asked for this, and we have a pretty good idea of what the outcome of the operation is going to be. These are pretty simple operations that we're going to do here. So ideally, I think we should be able to maybe make a change to the display while the operation is actually going, and then either prevent the listeners from triggering again so that we don't do that unnecessary work, or let them happen, and then when the notification gets sent to Ionide, we will just already be in the correct state. Like sort of, if you've done web services before, and I know Jimmy has, this is for all of you, there's this concept of optimistic concurrency, right? Do an action, assume success, update your UI so that you look performant. That's exactly it, Darren. I'm suggesting an optimistic UI update. So what if we could make the UI represent the destination state, so with the file removed, and then if we get an error from FSAutocomplete on the actual add, remove, whatever, roll back, right? If we do an optimistic update and things work, which we hope is the general case, then on the back end, MS-build will see the file change, will reevaluate, will resend a notification, And then when we handle that notification, there will be no visible change to the user because we will have already made the change. So that's my suggestion. And it's kind of a hack, but it is a hack oriented around making the user experience feel good in the common case. What do you think about that, Jimmy?
I think it's a pretty good starting point, because the simple, as you pointed out, the operation is fairly simple, and it's much easier to kind of backtrack from what we potentially had, and show the correct stuff later, or show it later. Like, but if we end up having the same state, you're not gonna notice it. You'll be able to click through multiple things here and just have that update. The only thing that we may have to start dealing with is if we have this being in a weird state, and I say, like, I'm going to move this up 3 times, for instance, are we going to have to handle some type of like weird concurrency issues there? That's probably the only thing we may have to start thinking about.
That's something that this functional Tom mentioned in chat, his question just a couple minutes ago. Will it also work if the user clicks fast up and down? Which is a great example.
Right.
We have a nice gesture for that. So my hypothesis is that there might be a short lag, but we will eventually reconcile correctly, because I think we have some debouncing on the project checking, like on the file watchers themselves. So my hope is that rapid changes within the same quarter of a second, half second, would get batched up and caught in one sort of update. But that's definitely something that we should validate as we work on a solution. Darren Hayes in the chat says, I was thinking along the same lines, optimistic UI, as I was watching, especially if you don't know or there isn't a single synchronous bottleneck that can be improved. Yeah, that's a really good point, Darren. And I think if we were, 3 or 6 months from now, and Ionide FSAutocomplete had deprecated the old language server, and adaptive was the only language server implementation that people used, I would be more likely to like fix it in a true way, or some way that did something in FSAutocomplete that sort of signaled to the watchers that, hey, trust me, I've got this change handled already, right? But I don't know if we will be in that space. and I would rather we do something now that works for everyone.
Right. And the thing that we're struggling against too is these files can change in order, right? So we may end up moving some file to a different position, and the thing that we're still struggling with is we need to ask MSBuild for this information, and we're going to incur that overhead no matter what. And there's some parsing and there's the evaluation step that Chet talked about, which is fairly quick, but it's still on the order of like hundreds of milliseconds generally. And then there's the design time load, which could be many seconds. And so that's what we're seeing here, is this actually taking a long time because it's actually reloading the entire solution. Now, we may be able to get away with reloading just that project, but because I'm skeptical of my understanding of how the whole project system would work, I don't know if we could reload at an individual project easily. And even if we did do that, would it still be a snappy UI experience? It might still be like milliseconds or seconds.
So I want to put sort of a reality check for the viewers right now. So a project system and everything that it does is a hugely necessary component of IDE tooling. There is no, so Microsoft has a project system. You can go to github.com/.net/project-system right now. And that is the project system, the open source bits that are part of VS, right? And there's a whole team that their whole job is maintaining that and making it fast and performant and analyzing through telemetry all the ways that it's not fast and performant and making it more so, right? The project system in ProjInfo and the project system like equivalent that Jimmy has made for adaptive, that's 2 guys part-time, right? So we're operating in a world of heuristics and simple and maintainable over incredibly fast. So like if that helps inform some of the decision-making process here, then that just be aware of that.
And I will say, if you find it underperforming, we accept pull requests.
Oh God, yes. We would take any and all pull requests in this area. That would be amazing.
So given that we kind of want to focus on the UI, I guess let's start with looking at the other project that we haven't even touched yet.
Yeah.
Ionide itself.
Yeah, so Ionide is also written in F#. It uses Fable to transpile to JavaScript, which then runs in Node.js inside Visual Studio Code. So you will see F#. If this is your first time seeing Fable, you will see some things that look weird. We've got functions like Objify. We have to deal with special functions like is JS undefined and is JS null instead of just null checking, right? So there are some aspects of this code that may look a little odd to you because of the like transpilation environment that we work in. But in general, in VS Code, to do anything, you have to register a command. And so what Jimmy is showing you right now is the Solution Explorer code in the activate function. Activate is something that you call on startup inside inside VS Code. And its job is to set up all of the registrations of your different components. So commands go in here, data providers go in here. For example, the tree on the left, we're not rendering a tree. We are giving a data structure to VS Code that talks about the different nodes, and VS Code renders that. So we have a tree data provider that is set up inside this activate. But we also have these commands registered. So f#.project.add file, clearing the Explorer cache, moving files up and down, that's all registered here. And in every case, you generally just unwrap the parameters and call some function for the actual definition, right? So this is just a real thin wrapper. So if we go look at move file up, for example, we are getting the project that the file is a part of and the file's sort of virtual path inside the project. And all we're doing is sending this data directly to FSAC. We do very little actual logic inside Ionide. And that's the goal, right? As much as possible, if the logic is in FSAC, then it can be tested easier, it can be validated easier. We just want Ionide to be a really light shim across. And what Jimmy's showing in the output panel at the bottom of the screen right now is the payload that FSAC got from that call. So it's a JSON structure. It has a fsproj property pointing to the project file in question. And then it has the sort of virtual path of the file in that project. So there's no subfolders for this particular file. It's just top level. Functionally dysfunctional in the chat says, dumb question, where does VS Code get the F# diamond logo from? Ionide or somewhere else? No dumb questions. Are you talking about the diamond logo on the left-hand bar there that opens the Solution Explorer? If so, that is a PNG file that Ionide, the VS Code extension, ships. Every VS Code extension has this huge, giant package JSON manifest that has to declare a whole bunch of different items in it. So that's the other one. If you go to contributes views, so the contribute section is huge, and like everything Ionide provides is in here. There's sections for color schemes, there's sections for commands. One of the sections of contributes is called views. So it's a top level property, Jimmy, if you want to search for that. or collapse the commands because it's super huge. Yeah, so here's all the different views. And there's the Explorer view. And you give an ID to a view, and separately, there it is, view containers on line 1586. They're in the activity bar. We put a certain view and we give it an icon. So that's how that's all coming together. Inside the Solution Explorer itself, though, you might see icons for solutions, icons for projects, icons for folders, icons for files. Those all come from your icon theme, which is a setting that you control inside VS Code. The job of Ionide is just to say, okay, this node in the graph is of a certain type. And then these icon themes map types to icons, right? So we're very decoupled. Jimmy could go change his icon theme right now and everything would just seamlessly update. So not that he should. So where are we going with this?
I'm not going to demo that. I'm not going to demo that.
Yeah. So Ionide has sent a command to FSAC, and FSAC is doing the thing. Our proposed fix is to not just send this request off. We want to send the request off and update our local data store for things. So we should maybe talk about the local data store for the Solution Explorer.
And I do not know it off the top of my head what exactly to look for.
That's fine. Let's just go to the top and collapse things, and I'll tell you when we get to something interesting.
Is there just a collapse all?
There is. Except it's fold is what it's called.
That's right. It's called folding.
Fold all.
Hold on.
Boom. All right. So let's talk about the Solution Explorer. I mentioned we're not rendering a tree. We are providing a data model, a description of a tree. There is I think if you scroll down a bit, Jimmy, there is a build tree. Yeah, or create provider. That's the thing. We have a tree data provider, line 317 there. And this tree data provider is responsible for providing the nodes in that tree to VS Code. And so the whole point of this is to sort of map our internal data model to VS Code's API. So this is a relatively thin wrapper, but it is still bound against our actual data model here. So what I'm looking for is where we pass in. Okay, there we go, root changed. That root changed function on 319, that thing is the thing that is tracking our model, our overall model. And so if you look at the, yeah, so that's root changed. If you look at where root changed is modified, it's probably going to be under workspace changed on line 742. That's it.
I was like, oh, you're looking for here, or?
Yeah, I was looking for what actually fires root changed.
Oh, let's see. Is this used anywhere? Let's activate here.
Yeah, there it is.
Is it okay?
I think it's that third one. Yeah, so node reveal activate. Okay, cool. Yeah. All right, there it is. There's the state. Okay, yeah. Okay, this is the thing reveal in Solution Explorer. Okay, so that, never mind. This was all a big red herring. I think the thing we actually want to care about is a function called getRoot. Yep. Sweet. Okay, and then getSolution on 266 there. Yeah. Okay. Yeah. GetSolution model is our guy. Great. Okay, so this is, remember when I was talking about workspace peak like 30 minutes ago? Workspace peak is our sort of top level model, our list of all of the actual projects that we care about. And a workspace peak is something we get from FSAutocomplete, and it can have a few different shapes. You can just load a standalone folder, which is the first shape here. You can load a solution directly. Oh, sorry, that's get items. What is WS? Oh, there it is. Okay, we're in get solution model. Yeah, great. So there's two kinds of workspace, a solution and just a raw directory. And so that's what you're seeing on lines 247 to 264. When we build our model of the workspace, we have this thing, set parent ref, that then goes and actually sets like a mutable in here. I think we just have a mutable value that is just tracking this thing over time. But once we build our initial sort of model, there's another event listener that is, that's interesting. There's another event listener that is listening for events from FSAC for when projects get loaded. And so that's what then goes and updates the individual nodes in the tree. Let me see if I can find that.
Right.
There's so many on did changes in here.
Mm-hmm. Okay, so this is this thing is view parsed. So this looks like it takes the loaded project loading state of this.
Yeah, so this thing that you were looking at is what you get when you do the open project thing.
Mm-hmm. Okay.
So depending on what the state of the project is, we show you a different view. And now you're saying, well, how do you know what the state of the project is? The project loaded events from FSAC get listened to here. So that's what I'm trying to find right now.
Yeah, do we have a listen or is it like a subscribe?
Oh, I'm dumb. Look at the very top of the activate function on line 734.
734.
Yeah,
Right.
so we have this emitter, and then there is a project level workspace changed event on 742 that we just fire the emitter on. So
yes,
the way we react to state changes is by looking for what uses the emitter, and the emitter is used immediately in create provider. And so we have this event that gets passed through to our tree provider, and then that event is listened to trigger changes in the tree data. Those event cases come through and trigger the different get ooh, sorry, my monitor just went completely black.
Oh no.
Yeah, I'm gonna have to reboot real quick. That notifications changed event is the guy, but I forget why we went down this. We were talking about how the tree gets loaded in the first place and all those things. We may just be able to set that aside for now and go back to the file modification guides, because before I reboot, what I think we need to do is in the, not the raw command handlers, the things that hook up to the VS Code calls, but like the helper functions that we have defined, we would want to update the model for that project. So there should be a way to, given a project, query the model for the data structure that matches that project, and then go munge that to remove the file or change the ordering of the files, etc.
Right.
You want to go hunt that down while I reboot?
Yep.
All right. See you in a bit.
All right. He leaves me all alone. All alone. So now that now we're looking for this move up event, and we actually want to track down in the model. So we actually do we actually have access to the model in any capacity, or is it only in this root changed? This will be the fun figuring this out, because what I expect us to want to do is mutate the model in some way during either this event or inside these, or return something from here, and be able to mutate it at the solution explorer level. So if we actually, let's take a look and see if there's actually any mutables that is going to make sense. So we have the node entries. I don't think this is what we want to look for. Is it maybe just the model itself? We have a set of things that we probably want to find. If we have a model, we probably want to find projects. And let's see, reference host, this project DTOs. This has project references, output types. Is there compile types, references? Not particularly. So what I'm also kind of looking for is just being like, where is the files that get output here? And it might actually be output types, but I'm not entirely sure. Well, one of the things that we could potentially try to do is do the debugging, but I don't think debugging works too well with what we kind of have in Fable currently. It's not the best experience from what I remember. Loading, create events.
I made it.
Oh, you're back already.
Yeah.
That reboot process is much faster these days.
All right, where are we at?
I'm just kind of tracking down like where because there's these different models, or like I was looking for potentially some type of like mutable model, but I don't think that exists here.
Yeah,
Not
so
easy to access.
So this is an interesting sort of data point here. This model, the tree structure that you're walking down there, it's immutable, like it's a DU, and it's that model DU at the very top of the screen or at the very top of the file. But the first position in every single one of them is a mutable reference to its parent.
Mm-hmm.
Right. And so to make this kind of edit, it feels like we need to alter a DU node and then patch up its parent, which feels weird, because if you patch up its parent, then like you got to walk the tree all the way up.
Yeah, that's true.
Huh.
Because what we'd really want to look for is being able to get this model and then basically like, sub in nodes for ourselves. But if we have to,
here's
do it immutably,
potentially easier / dumb thing. So if you look at the model at the top of the page, or at the top of the file, line roughly 28 or 30 or so, that's where we're defining the thing that we're working with in this entire file. And so this is the project loaded sort of state, is the DU case on line 28 here. What if for files, instead of a model list, we had a model resize array, or a model or a mutable model list? I would probably go resize array here.
Let's try it.
And then we have to fix up a couple places that were using lists directly before, but then it makes it easier for us to just change the one thing that we need, right? So what are we looking at?
So
Yeah,
we
yeah. So
have-
there's some helper functions that are getting, that are trying to get all the folders. Oh yeah, good point.
It turned off warnings, or don't show warnings, but I'm still seeing warnings. Awesome.
That is super great.
Okay.
But yeah, so this is the kind of stuff I would expect when we change a data type, right? So I think we then go through some of these helper functions, like create new file dialog should just take a resize array instead.
Mm-hmm. Ah, yeah. See, like right here in this add file, this is potentially a place we could also update these resize arrays.
Yeah, yeah. So we wouldn't necessarily want to do it then. We'd probably do it in the event handler on that particular case, but yeah. Because this is prompting the user for things, and then that promise map on 871 is where we actually then go fire off the.
Right.
When it said fold all, it really meant fold all.
Yes, it did. That might have been a little aggressive.
Yeah. So what do you
so
think about this
let's-
path in general? Just like fixing up the types and then trying to make the change?
We can always just give it a try, right? And see
Yeah.
see what happens. And if it doesn't work, well, that's kind of the exploration process. A lot of this, right, is we end up having to try these things, and if they don't work out, then we need to just convert this to a list. Going to do a lot of the dumb things, and if it doesn't work out well, then that's the thing that's about a lot of this kind of more complex work. Is a lot of this ends up being very exploratory. Like, what could you actually end up like making work?
Yeah, so
So
this looks like a change
this-
that'll be a little viral, right? So it'll start us, like, do we think a solution, or do you think we will ever be in a case where we will want to do a similar sort of optimistic thing for a solution? And if so, then let's go ahead and change solution to also be a resize array. Otherwise, let's just stay on, like, let's stay on the conversion, like convert the thing to a proper list path that you're on, let's keep the scope small for now. So let's do the map like you were going to do.
Yeah. This will be, obviously there's a lot of things that could be better, but let's see. Expect to have type.
Why is
this
that?
because is it because this is like returning a list here? Or maybe I have something, I don't have something higher in the file, right? Oh, is it because we're doing the multiple pattern matches?
Oh, yeah.
So these are different.
So maybe that's a
now.
reason. Maybe that's a reason to make solution just be a resize array too.
All right, let's do it.
Oh, God.
Very viral change coming.
Sorry. I regret it. I regret it already because I see so many other items, model list parameters on here.
That's fine. We can just basically duplicate this case.
Yeah.
Unless we do you want to abuse active patterns then turn this
Nah. Let's limit the compiler crimes we're doing when other people can see.
Okay. Model. Am I wrong now? Did I mess this? I took away the list, didn't I?
Yeah.
Don't do that. Guess we'll just do the simple thing here. Do seek.toList to get everything nice and compiled.
Sweet. And then you'll have similar down in the bit below. So in this one, instead of converting seek to list, we know we are going to want, or we think in all of these commands that are manipulating the files, we're going to want to manipulate the thing. So instead of converting it, because you got to remember we're in JavaScript land here, so seek to list might not be necessary here. I would rather just change like create new file dialog to take the resize array. Because I don't really think much of the code here will change as well. We'll just seek.tryfind instead, and then boom.
Ta-da.
Yeah.
All right.
Sweet. Okay, we're green. So what did that get us? Nothing initially, but now we can try to do the optimistic thing that we're talking about, right? So I think for add below and add file, there's not an add above, is there? Oh, there is. Okay, so for all these adds, for example, they all follow sort of the same pattern. Make sure we are in a project. Then if we're in a project, prompt the user for what their new file name is going to be. And then if they, excuse me, hiccup attack. If they give us something workable, then ask FSAC to go do the thing. So what I would like to do is maybe change, I want to make some helper function that we could reuse in each of these that is, you know, optimistically go add a file to this, right? And I think that function would need to do, well, so at minimum, it would just files.add new thing. Right.
Yeah, I think, well, let's make sure we can clean up that kind of stuff later, but
afterwards.
Let's just kind of get the let's get like the proof of concept out of the way, I think, instead of trying to be super. I can clean those up later.
Okay.
Or we can go.
So then
the
most important thing is that I guess we would spawn a new promise right here. So I guess what I was thinking about was do the work, spawn the add file above promise, and then add a reject handler on project.add file above that would undo the addition. Does that make sense?
Right. Well, this would come back soon, right? We wouldn't want to. Oh, I guess
it is
in the
possible
case,
for it to fail.
Right.
Yeah.
Right. It is possible for it to fail, and we'd want to undo that there. That's true. Okay.
Yeah.
That makes sense.
So
is there any helpers for that already? Is there like a promise to reject? Okay, cool.
This creates a new promise in a rejected state already. You want promise.catch, I think.
Okay.
Yeah.
Promise.catch.
Yep.
Okay. That's right.
Sweet. Okay, so I guess on 838, above 838, we want a new line where we would like create the new file on the current model. So we would go files.add something.
Well, let's keep an old version of the state. Because it'll be easier to replace.
Okay, so we'll need to copy it entirely. So yeah. Yep.
And we're not dealing with like hundreds of thousands of files, so I don't think this will be too big of a problem.
You're probably exactly correct there, yeah.
Unless anyone out in the crowd has projects with that, you can speak up.
Completely fair. So now we still need to make a new file model thing and add that to files. So, and we need to add it in the right position.
This one's add file above, so we want to manipulate. We want to move basically the index of where that file is.
Yeah. And so we know the current file based on its virtual path. So what we need to do is look at all of the files and do like a try index of where vert path equals.
Right.
Yeah, try find index.
It's going to be virtual path, right? Can I not actually type? Go.
Yep. And the file is actually like a typed structure here, I think. So yeah. So you will need to get, so you'll even need to match on it, right? So
right. So I need to go find what the type definition of. So we need to find a
it should just
project?
be file. No, you need
a file. Oh,
the
yeah,
things in the file list should all be files, but the way we've structured this, you don't know that.
Okay.
Because it could be a folder as well, directly
right.
underneath a project. And then you've got to wrap that whole thing in parens too. That's why it's complaining.
Yes.
Do we have a quick fix for that yet?
Probably
Wrap
not.
everything in parens.
Hey, everyone, you wanna try to do that?
Okay. So, and in this
fix.
one, you've got to match on it as well because it could be an option model. So
it's a ref of option model. Do we have to deal with the ref here? So that you a sum. Is that good enough?
Yeah. And so then instead of just I see what it was. You were binding to the parent. You don't want that. You want to explicitly pull out the virtual path.
Oh, that's right. I have multiple things. So this is a virtual path. We'll do.
Yep. And then you'll do VP equals vir path or whatever. Or that. Yeah, great. So this will blow up for non-standard things, but it's fine for us to test the concept. So that's the index of the file that we are adding above. And so we want to add a new thing at that index -1, I think.
Yeah, we basically want to move like the array, right?
Sweet. So you should just be able to do files like insert at or something like that. I forget what the actual. Yeah. Boom.
And then,
at the specified index. So.
Well, this is going to be blowing up on negative, but we'll.
Yep.
Oh, is this? This has
to do error checking.
Right. But a lot of times that's what you want to do is you actually want to get rid of error checking just to try out the.
So the thing that we'll be adding here. So I think insert actually does.
Do we need to go?
We need to make a new file.
Oh, do we?
Yeah, because like look at the signature of insert here.
Well, it takes
so we are inserting.
Model.
Yeah, so like this is where we would put the new file, the structure representing the new file in.
Right,
we would insert it at the
I just grab that file right from our previous index because I'm just moving this node.
No. I'm saying you don't need to move it because resize array handles the shuffling.
Is it? I think I'm missing something. What's?
Okay, so you can insert at a position, checking to make sure it does actually shuffle.
Because I was thinking basically what we'd want to do is insert at that current position and remove it from its previous position.
Well, no,
or if
this isn't moving.
There's a better.
This is adding a new thing. This isn't moving an existing one. So we need to add a whole new...
this is add above. Oh yeah, you're right.
Yeah,
you're right. Okay.
So
okay.
Effectively, that should mean add at the index of the one that we currently have selected. A new file.
Yeah, I was for some reason thinking I was in the different file handler for whatever reason.
Yeah,
I was thinking above moving files, not add above. I was thinking I was move above, so that was my bad.
Gotcha.
So now, we need to create a new.
This should be model.file should be the constructor for it, and then we can go piece by piece and see. And so we
Yes.
will need to link it to the parent. And so I think we can get away with that just by doing an as on the project on line 831. So instead of, yeah, that's it exactly. And then
Is this the wrong thing? Because
oh yeah,
I
duplicated
need to
as parent would probably be fine.
here we go.
Perfect. All right, so that'll be the parent. And then no, you don't need any of that. You just pass the whole thing in for the first parameter. Mm-hmm.
Yeah. Okay,
Next parameter.
Right.
So the path is going to be the fully qualified path of the thing, which we don't have yet. We have the user entered the relative path. And so we need to do like a path combine of maybe our sibling file that we just found.
Yeah.
Actually,
How-
hold on a second. What does handle untitled do? Because it might already do the path normalization.
Untitled. It ends with FS. It just
no. Okay.
concatenates.
Okay, so we do need to make the thing absolute still.
Yeah. What path techniques do we like? I'm more familiar with the BCL, but I'm not familiar with like the JavaScript world. Is there specific path things that we have to deal with, or can I just use like what I know?
Yeah, I think you have to use path dot, and I think that's a module that is available, lowercase p.
It was path combine on this.
We use it in other places in here, so it may just be a missing include.
Node path dot.
Yeah, there it is. Yep. And now we need to combine the base name of our sibling file and file prime to get the final thing.
So say this is the sibling, right? Sibling file. I guess the sibling file index. And we need to actually get that. You know, we're never going to do try find. We're just going to do find. Again, error handling later.
Yep.
And then let's say let sibling file.
What is this dot index or nonsense?
Error handling later.
Rolling old school. Okay, yeah. So, and if you want to just really throw error handling to the winds, you can directly match on files.sibling file index and unpack it as the file to you, right?
Yep. Good point. Because we need file.
In this stream, we don't care about error handling at all.
Yeah. Do not take this as a thing we're going to do. This will be cleaned up later, but this is we got to do proof of concept work. That's what we're doing.
Yep.
So we care about the path, or
yep, you want the path and also the project path.
Okay, path.
Which we could probably also get from the parent project in the match on line 831, but hand wave.
Or did I give it the right name? Yeah, it's project path.
Yep.
Okay.
Sweet. Cool. So now when we're making our new file, we can steal those things directly. Or at least use those things.
Base name.
Yep.
Sibling. Base name.
And now for our expected new file path, that'll just be node.path.combine sibling base name and file prime.
So combine, join. All right. Sibling base name, and we said which one we want is the
File prime, because that's the one that should have appended the extension if necessary.
Ah,
And
you're right.
that's necessary, folks, because when you just control N to make a new file in VS Code, you get a file with a URI of untitled : / randomly generated, like not randomly, but some pattern generated file name, but there's no extension and there's no language associated with that file. So then you can say, hey, use F# with this, and all of the tooling will light up. So all of the tooling has to be aware that there might be a file in use that's not .fs or .fsi. Sweet. So our virtual path is going to be file prime, actually. Maybe.
Oh, is it?
Oh no. It's not entirely going to be. We're going to have to compute that
Oh,
too.
right. Oh,
Because,
yeah.
But this is a similar sort of thing. We can get the base name of the sibling file. So you'll want to pull that out as well. Or the base name of the sibling file's virtual path. And then glom this onto it. Hooray.
And so this is virtual path. You know what? Because I think I'm going to be losing some like interesting context. I think I'm going to want to do. I don't want to pollute my path. Just call this new file.
Mm-hmm.
Let's see.
Sweet. And then we'll want to pull out the virtual file path.
Right. Okay, so now I need the new file virtual path. This fun stuff.
Yep. And then we just flow it through. Now you can return the new file from this scope. Huzzah. Okay. So theoretically, we've optimistically inserted a file. So now on the recovery step, we would just remove that, which means clearing files and resetting it to old file state.
Right, because now we actually have files.
And it's a
No, it's
mutable
not.
thing that we can.
Yeah, so
We can't like overwrite the entire reference. So what we have to do is clear the whole thing and then add range of old file state.
Yep.
Huzzah. Okay, so what's complaining?
It's going to be a pattern match, obviously.
Yeah, that's fine.
That's an optional. So
well,
I guess that's fine.
I don't think it's ever really optional.
Yeah, but I can just do the fun, like.
Oh, option map.
Just option map my way to success.
Accurate.
And so now we have this. Technically don't need that. So yeah, I could do these two things in one go, but
Meh.
we'll do that. We'll do it later.
No, I'm reaching across the internet and smacking down Christian Sheridan. We are not doing bonus crimes by using option.get. Hey,
let's
actually, Jimmy,
see.
is FS Toolkit error handling Fable compatible?
Yeah, absolutely
All
it
right.
is.
Bonus later, we'll bring in an option C.
All right.
That's the deep
it-
cut content.
I mean, they're like, so when it comes to Fable compatibility with FS Toolkit, I'm doing like kind of like the bare minimum. Like I'm definitely running all my tests against it, but there's like weird intricacies about different versions of how it behaves. And so depending on the version that we're using to compile, it may not work as expected. So that's something we have to be aware of. All right, so now I need to actually create like, I'm gonna just do a ref this. All right. And then, yeah, well, do we have warnings as errors, or is this actually gonna just compile and let me go on my merry way?
I don't think we have warnings as errors. So yeah, so you're right. We could try this now. So if we like F5'd.
Oh yeah, so we should talk about this little helper here. So when we, Chet and Chris has graciously made a nice little launcher to be able to launch Ionide whenever you make changes. And so there's a couple of them here for being able to build and launch the extension. So I'm just going to go ahead and run that. And then we'll actually see a little new terminal pane here, extension build, and you get to see what it's doing. It's running our fake script, running the compile steps for Fable, and then it'll eventually it'll actually stand up a whole new VS Code instance with our new installed thing. And oh, look at that, FS Toolkit, it's already opened.
Let's to a FS autocomplete custom path that you have locally, or is it?
Nope, it's still using. So this is a custom build of the Ionide extension, and the Ionide extension by default includes its own version of FSAC. You could, go double custom, and then in this custom build of Ionide, set the setting that chooses a different FSAC. But that's not necessary for this fix because we're not making changes to FSAC.
Right. Yeah. I was thinking more in terms of you are, creating a quick fix and you wanted to quickly test it on Ionide, so you can, double custom the path and then test it quickly there.
So the really nice thing about quick fixes is that you don't need a custom Ionide to test them. All the quick fixes go through the normal. There is a code action, like quick fixes are called code actions in the LSP sort of API, and they are something that is already well understood. So adding a new code fix or code action to LSP or to FSAutocomplete automatically surfaces it in any version of Ionide without any other changes.
Yeah, if you wanted to test FS, this is slightly different dev experience, but if you only need changes to FSAC, there's a setting here called f#FSAC.net path, and you just point to the path that you just built your new FSAC, and this will, on restart of Ionide, will rerun your new changes.
Mm-hmm.
All right, so now we have a giant thing here. So I guess we want to try to add a file above visible.
You're in. Yeah, just choose any one and open the project file for it first so we can see the stuff happening side by side.
Yes. So let's go here. Let's actually close others, and then I'll open
All right,
this
so
one back
when
up.
Jimmy adds a new file above an existing one, you stop, it opened the CS proj, or it moved the CS proj. Why? All right, so when he adds a file above, we should see that change happen in the CS proj, but we should see it happen simultaneously or earlier in the tree here.
Nope.
It did not. Okay, so this is where debugging is helpful. So I have a suspicion. I didn't mention it during development, but I have a suspicion, and that suspicion is if you look at create provider, one of the inputs to create provider was a change signal. And if you sort of fold out all the overrides for that provider, there's on did change tree data.
Oh, we're going to have to fire that
It's an
event,
override.
you think?
I think when we do this manual change, this manual trigger change, we are going to need to trigger this event.
Okay.
So
do we have access to
what
this
we do,
object?
yeah, so, well, we need access to the tree data provider itself.
Right. So where does that get?
Provider. So there's a local that is set in activate on line 738, or roughly, because you've got changes.
Right.
That may need to be elevated to be like a module mutable.
Well,
something.
are we registering these commands and we did this work? So we have access to this provider.
Oh, okay, yeah. So pass it in
and
as
this
a
activate.
parameter. Yep.
I don't think it needs to be passed. It's just, closure. You can take it.
Yeah, I meant
because it's here.
Oh, we're still in it. Okay, yeah. So when we refactor,
yeah.
we might end up having to, but yeah, for now we don't.
Right.
So you should be able to, after we add the file, say that and pass in this, like the project that just had its files mutated.
Okay, so then I'm gonna have to create a U3
You'll need
option
to
event
trigger it,
option.
I think. Yeah.
Oh, is there actually there's a trigger?
Well, provider dot on did change tree data dot.
Oh. Oh, there's the value because this is itself an option.
We're always providing it. Just do the thing and then invoke.
Aha.
So this is what you pass the U3 to. So this is going to be a case one of a U3, and you'll pass in this, which is what you've named the project.
So do U3 dot case one.
Case one. There's a operator for it too, but blah.
Yeah, I'm not going to scare people
and
with that.
Actually, that's not going to work because this is an option still, because of where you put the name.
Oh, which one?
Yeah, so see it's erroring there. The this that you bound is the option of the parent. And so what I would do is I would change that to make this be just the project inside.
Right.
And then that will break your other call site down below just a little bit, but then you can just say ref sum this, which feels like a crime. I'm pretty sure it is a crime.
What's the problem here still?
This is you can ignore this. You get a weird return.
Oh, do I have to like box this somehow?
Oh, it's a function? What? An option of thing to thing. Oh, it's a listener. Listener function that we called when this event happened. Are you kidding me? We should be able to invoke this. There's something I'm missing here.
Do we do this kind of like, we did on to dispose. Let's see, let's look at this. This is an event. Yeah, it does some like boxing.
Oh, well, hell. Just, I guess, double bang that. And then ignore the result.
Yeah, this is
just
if you're not familiar with Fable, but yeah, if this is not familiar with Fable, there's some fun boxing stuff you have to do sometimes. All right, let's give that a try. Let's close this. Now, I haven't tried the watch mode. Does that work well in your experience?
I have not tried the watch mode.
Let's not do it for.
Oh, I see what it is. Okay, we have the wrong data structure in there. So.
Oh yeah, you know what? I didn't do that in the right place, I think, anyway. This needs to happen after we do an insert anyway.
I think we want an event emitter that we can fire. And so I think instead of what you were doing before, you want the root changed event, but I'm not, or no, sorry, there's a property called emitter that is available to you in the context that we're in. And I think that's what we want. Yeah, fire is what you want there.
Ah, okay. And
Yeah,
then
and this
pass
is the thing that
in.
just takes the T. Yeah.
Okay.
Yep. And
Some.
all right. And so now you can get rid of the provider on did change, blah, blah, blah. I think this will do it. And obviously there's a lot of cleanup that needs to go on, but this should at
But
least.
proof of concepts. But if we get this proof of concept working, I think that's pretty much a good, like, this is the proof is here. Just gotta mechanically go through and change all the places that we want that to be and blah, 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 blah,
Yeah.
blah. Right.
Give better names, make something tighter around it, etc. Right,
All the
so we
stuff
wait
that's
for the
not so
loads.
cool. All right. So now we want to. All right. So because every time I click on a file, so I got to be careful about that. So now I want to say new file, hello world.
Boom, immediately added to the back end. And if we had the output window open during this, you would be able to see the
Oh, look at
messages
that.
coming back and forth.
It hit
Ooh.
itself.
And then came back.
Well, it came back because it finally loaded everything, but there was something
Yeah.
that triggered. That's.
Oh, you know what it was? Yeah. So bring the output panel up and go to the F#, blah, blah, blah. And do that thread again.
Well, all right. Clear you. Let's make sure we're here. Add file above. Hello 3. So this did change.
Yeah.
So what happened here is these logs are saying like these functions changed or these things changed, but we're not actually loading the projects yet because of that lazy nature of this. But you can see that it definitely did send up the request.
Yeah.
But now,
so
let's
we got all these project
create
loadings.
Let's take those logs, put those aside. I'm going to clear the output, and then I'm now going to go try to get type check information. Or did it not disappear this time?
So what I think
guess
happened was there was another workspace loading or project load notification that happened independent. But since FSAC's state had not been changed, it was using like that cache state to return along.
Let's go here and then go over here. It does disappear, so there is definitely
yeah.
So if I got to be quick enough to catch it, it looks like. So there's definitely some type of like load notification.
This is something I would expect to present differently on the other language server, not the adaptive.
Right.
I would expect the fix we've made in Ionide so far to behave the way we expect on that one. Isn't it getting added in the wrong place? Are you adding above visible 2, right?
Oh yeah, I just added. It did look like it got added in the wrong place for that one too, because that's probably that concurrency
I think that's
problem
because
that
you
we're going
went
to talk
index. Well, I think it's because you went index -1, right? And you just want index.
Yes. Oh yeah, you're right. You're right. Good point. So let's take a look and see if there's anything here that's didn't get.
Yeah. So the states do get changed for workspace notify project loading. So that's
right.
And that's coming because you're doing like a full reload of everything, right?
Right. And so it's going to actually grab information.
So we would I think want to go look at the handlers for project loading and see what it does in the event handler when the project has already been loaded, but we get another one of these project loading ones.
Quite a bit of places where we handle project loading.
So first one is
Step
definition. Yeah.
State get submodel, don't care. Get label, that's just for showing.
Just helper functions. We probably should make
Tree
those
item?
properties on the thing. Tree item
Yeah.
is
I don't
it's collapsible
know.
state. Okay. These are all just like view helpers. None of
Right.
them are actual loading. Get model per file might be interesting. When is that used? Recursively, sure. But
On
what's
model
the-
changed.
and then the new state gets overwritten. Yeah. So that's, I think that could be part of what's happening because the project loading notifications come in. Project loading doesn't have files on it. But if that were the case, I would expect the view to change pretty gnarly.
Mm-hmm.
Oh, you know what? Maybe not, because the root changed is getting invoked and triggered. Or when root changed is fired, then on model change is called. But it seemed like the thing that actually triggered the view state to change was that emitter getting fired, which is different.
Mm-hmm.
So we're close. There is another possibility, and another way we could maybe handle this is to do the same kind of change we just did, but in FSAC instead, in the state there. So if on the add above, add whatever handlers, we internally mutated the state of FSAC in a similar way, and then triggered a project loading notification with that new content, then the editor would say, oh, look, project loaded with this state, and then refresh. So there would still be a call.
That's what I'm wondering. Because it seems like it's using old state somehow. But we'd want to do a like project loaded sending down.
Yeah. Do me a favor. Switch to the non-adaptive LSP.
All right.
And run this thread again.
Settings.
We are just about coming up on the time that I can
same here.
Spend on this morning. So we will have to look at winding down.
But yeah, this gets into the fun debugging part of how things work. And so
you switched and it's loading all the files. You're still in static graph mode though, right?
Yep.
Yeah, so everything just lit up at once, which is what I expect. And then pick a project, any project.
It does disappear and come back.
All right. Okay. I mean, and it's still the same root cause because it's just in my case, if you check in the output logs here, I bet you will see a project loading, project loaded pair, but this time just coming for that one project from project info.
Right.
So, okay, so it's the same core issue, and that suggests to me that we will need to do something. Oh boy. Oh dear. Two paths forward that I see here. Even if we did a hack, or even if we did the same kind of change in FSAC, the underlying project system for either adaptive server or regular adaptive server would still send the loading loaded pair. So the core question is, how should the Solution Explorer behave with an already loaded project when a loading notification is specified? And I think that's what we need to change.
Yeah,
right
that's good.
now, we do like a pure state, like whole state overwrite. And I think instead what should happen is like every other event sourcing thing that we've done, right? You got current state and you've got event. What should the transformation be? And we should just have a different transformation when the state is already loaded project and project loading. We may need to expand the data model to support that, because like maybe in the UI, when you get a new loading information, you would want loading ... to show on the project, but still have access to the old state.
Right.
So,
and that is a much bigger change, probably.
It grew a little bit, yeah. These this is, for everyone else, this is not uncommon working in editor tooling kind of overall. If you are able to stay within the lines of like the raw LSP spec, right? If you're making a change to completion, or if you're making a change to the way tooltips get rendered, those are generally fairly localized, right? You can make a change in FSAutocomplete, you can test it, and you can just hover over the thing and see the change and iterate in that way. When you start dealing with UX interactions, and I'm sure any of you that have done web can sympathize with this, like the 60% part is easy, and then the 40% of, but this one corner case and this one thing, like oftentimes is the dominating piece of the work, right? So I think that's where we're at here. We have a decent mental model of the proof of concept that we would want to do here. An optimistic addition with a rollback in the case of error. That has sort of surfaced a logic or UI problem that we have around state synchronization or decisions we should make with certain states when transitioning to the next state. And so that might mean a change in the data model, etc. So I think that is an okay place to leave this one, but there's clearly some more work that we will have to do to get to the desired end result. But we know what that work is now.
And definitely one of the goals of these sessions is, to do the exploratory part, to do the, the investigation and come up with a suggestion, with a plan for you as a contributor to take it away, finish finish the PR, clean up the PR, clean up what we are trying to fix, and then submit a PR to the respective report. In the last session, I fixed it. I thought I fixed something on. I found a way to fix something on the compiler for a range, and after we did almost 2 hours or more than 2 hours on there, I went to submit a PR, and then I got a review from one of the contributors, and he pointed out, have you considered maybe the other one, a different solution? And it pointed out basically. It showcased that I was not covering all the cases, so that is, that's awesome. That's why we are doing this, or why we have this initiative to bring you together and have expertise from people like Chet, like Jimmy, like Florian, like myself, where we can,
I do want to put an asterisk on that though, like expertise. Hopefully, what you took away from this was that Jimmy and I do not know everything about the software that we have made, right? Like if Chris was here, Chris might also have some additional insight that might have made some parts of this a little easier, but there's a good amount of exploration in these things. And Jimmy and I aren't special in that we know everything. We have some context and we're stubborn. Like that's it. So
that's a great way to put it. Stubborn is very, very true. It's don't give up after the first hurdle, especially with developer tooling. There's just because there is a lot here, that we're also relying on. It's like these things, like the things that Chet talked about, is like we're relying on VS Code to show this data structure in a way that we want it to show. And, you kind of have to start getting your mental model. Like, I don't understand that mental model. I don't have it in my head, but that's something you have to learn as you progress to do this kind of stuff. And it's very similar to any of these things. Is there might be something specific, like we could choose to do a code fix, and you're gonna have to get the mental model of how the AST works. And so I don't really have, like, the AST is something I don't have regularly in my head. Edgar might have a better understanding of that generally, but that's also like something you just gotta keep pounding away at, and getting just don't let any hurdle discourage you.
Yeah, definitely, that's really good advice. Yeah, I mean, we can have maybe in the future, I don't know, in the next session, you can show us, what was the end result of that, or if you go to continue in a future session, let us know. We're always happy to have you both here, because, Ionide is a big part of what we, as F# developers, we use it in our day-to-day. So, yeah, thank you very much.
Yep. Thank you for doing this.
Thank
And we'll probably have another session of these I'm sure sometime in the future.
Yeah. I just received a request for a session to include a code fix on Ionide. So we will have a session on Ionide future. So
love that. Jimmy, since you're still sharing, you want to go show the source for that sequence diagram real quick? Some folks in chat have said that was super helpful, and I want to show how simple it was to do. So can you view the history of it nicely? If you do the next to edited, there's the drop down. And if, like, I guess so the Mermaid JS is a thing that GitHub supports now, and it's really easy to make sequence diagrams or make little graphs. It's the same language that Jimmy used to make the other graph showing all the different components. But a sequence diagram like this was very straightforward to make. You just say it's a sequence diagram. Each actor is one of the sort of components of the system, and then you just have little messages from A to B, and it doesn't matter, and they're roughly ordered in the overall duration of the operation, right? So very low effort, very high reward, I think, in terms of making it easier to communicate things to people that aren't actively in your brain at the same time, right? The only distinction on this change here was between actors and participants. Actors get a little human stick figure, and participants just get boxes, right? So that was just to make it look a little nicer. So definitely take a look at that, and think about incorporating it into more places. I don't know if it's supported in FS Docs though. Do you, Jimmy?
I think if you wanted to support it in FS Docs, I think all you need to do is add the Mermaid plugin, or like the Mermaid JavaScript, and I don't think it's gonna I don't think FS Docs is gonna render it. I think it'll just come out on the page, and then just let your JavaScript handle it.
Perfect. Sweet. Well, that's all I got.
Do we have any more questions that we need to go through?
Yeah, maybe I have a quick question, or just a confirmation, if you still have a couple of minutes.
Yeah, I still got some time.
So like the code we were looking at, so this was a Fable code, essentially, that was basically using what I would suppose some API that the Visual Studio Code provides, right? So the whole kind of model processing and event system and so on, this is probably coming from the Visual Studio Code, and there must be some documentation around that.
There is, yes. I will drop links for that. We have IntelliSense for them, and we have tooltips for them, because there's a separate project in the Ionide org that is Fable bindings for the VS Code API. And that's over under Ionide VS Code helpers there.
Okay, so
that is generated using TS to Fable from the actual types, or the TypeScript types, with a little bit of manual fix up, because there are some things that TS to Fable doesn't handle super well.
Okay, so to understand like the whole model, how the events are handled and so on, it's probably best to go to that documentation because this is
Yes.
not something that you wrote actually or invented in this case, right?
100%. There are
Okay.
sort of, and there's sort of a stark split between things.
Mhm.
There is things that are provided by the LSP contracts,
Mhm.
and those are sort of implicitly, those are automatically hooked up to the appropriate VS Code APIs
Yeah.
using the VS Code language client Node.js package. There's a portion of Ionide that is entirely around configuring a VS Code language client structure with configuration about how to find and launch FS Autocomplete. And once you do that, everything LSP is out of the picture. You no longer have to care about it. Everything else in VS Code is binding to, or sorry, everything else in Ionide is binding to specific VS Code APIs to get some benefit out of it.
Okay.
For example, VS Code has a concept of tasks, which are just like, one-off commands that you can run, or orchestrated commands, and tasks can be provided by many things. If you are in a JavaScript project, there's an automatic binding from the Node.js tooling that creates tasks from your NPM scripts, for example. We do that for build. And so you can run tasks, and I think it's just like task : or whatever, to build the current project in debugger release or build the current solution, etc. All of those are VS Code tasks, which means they plug in nicely to any extension that integrates at a task level. Similarly, we provide automatic debug configurations for projects that can be run and debugged, tests and applications. There are some, and that is just a bridge between things that .NET knows about your project and a structure that VS Code knows how to handle. And that's all. That sort of philosophy is all Ionide is, just tiny bridges between information that the F# compiler and MS Build have about your project into functionality that VS Code provides.
Okay, cool. Thank you.
Thank you, everyone.
Thank you.
I am
Yep,
going
thank you.
to reclaim host.
I look forward to everyone making pull requests.
And also shout out to the people that do find an area that they want to go nuts on and contribute on. There's been a spike in contributions around like the Test Explorer system in VS Code that has been really cool to see. People like use it, find an area where there's a gap, identify the gap and fix it. And that's what we're here to help enable, right? To help you solve the problems that you find, and occasionally to solve them ourselves when we have the time.
Definitely. Please consider submitting sessions if you want to contribute to Ionide, FSAutocomplete, the compiler, Transformers, any open source project that basically you are using or you're interested in using.